Praise and gratitude to the Almighty God who has given us health and opportunity, which despite the coronavirus outbreak, we can still attend the seminar activities in online. Assalamualaikum warahmatullahi wabarakatuh. Thank you very much for the opportunity given to me. My name Jacob Lekikwatil from STT Mandala, Bandung will represent the author team to present our journal paper entitled Electrical Energy Alternative of Magnetic Field Around Wire of Power Line. Background. First, electric energy crisis and consumer needs. Consumers are increasing while the availability of the electricity is decreasing. Second, the existence of electric line with alternating electric current generates a large magnetic field around and along power line that store electrical energy but that has not been utilized. Three, there are public concerns about the danger of electromagnetic field radiation near the location of the power line. Purpose of this journal. First, utilizing the magnetic field that is on the primary power line and making it a new source of electrical energy. Second, making an equipment that can take the magnetic field flux into an alternative magnetic power based field with a voltage of 220 volt to provide electricity to the community near the location. Third, changing people image about the danger of electromagnetic field radiation. Next, the basic theory. To understanding in the electromagnetic field technology on electric power line is based on the Maxwell law, Faraday law, and several other laws. Illustration of electric energy around the power line by Maxwell law. We can see in figure 1. If electric current flow in wire, will generate magnetic field along the wire with a magnetic field encircling the wire by Maxwell law. This electromagnetic field around the wire and density, flux density depending on the radius of the circular of the electromagnetic field. Large of distance of radius, small of flux density. By Maxwell law in equation 1, closed circling integral of the intensity of electromagnetic field is equal to the areal integral of the current density flow in the wire conductor rods. And how to take the magnetic around the power line. We can use toroid. Toroid is equipment that function the same as a transformer. However, with the primary and secondary winding, collects it in a number of turn of copper wire. This coil is used as a secondary winding and tool, which is connected to the load. And the electric power line wire is passed into the toroid cavity as a primary coil N1, which flow primary current I1. Then if we want to determine how much power the load lamp can be supplied with a voltage V2 equal to the rated voltage of 220 volt, right? Then the equation is as dependent on I1 current flow in power line, and V2 is the voltage occurs on the load. V2 asterisk is the name capacity of voltage of the lamp or the load in equation 12. K is a constant related to the nature of the toroid material. And this voltage on the lamp or the load dependent on the I1 current flow and power line, and dependent to the voltage or capacity of the lamp and power capacity of lamp or load. And how to take the data? We made a simulation experiment 2 ways. One way is look in the fix 3A, and second way we used the 3B. The experiment result of experiment 1, we can see in the table 1A. The result of an experiment with a low current of flow in the power line of 27 amperes. For incandescent lamp 5 watt, the voltage on the lamp 160 volt. Description lamp is dim. For incandescent lamp 10 watt, the voltage curve on the lamp is 60 volt, and description of the lamp is very dim. An electronic lamp 7 watt, the volt current on the lamp is 200 volt. Description lamp is bright. From the result of the experiment with a low current 27 ampere on all incandescent and electronic lamp, dependent of the current flow in the power line. Incandescent lamp 5 watt and 10 watt is very dim because the primary power line to generate magnetic field is weak. In the second experiment, you can see in table 1B, The result of an experiment with a medium current of 80 amperes. For incandescent lamp 10 watts, the voltage occurred on the lamp is 234. Description of lamp very bright. For incandescent lamp 40 watts, voltage 225 volts. Description lamp is bright. Incandescent lamp 60 watt voltage occur on the lamp 165 volt. Description lamp is dim. But for 15 watt electronic lamp at 80 amperes, power supply current flow in the power line cannot detect the voltage value because the lamp suddenly explodes and goes out. Voltage occurrence about greater than over 250 volts. Next, result of experiment 2. In table 2 is result of experiment with a medium and a large current. For incandescent lamp, 40 watt, need current flow in power line is 70 amperes. For incandescent lamp, 60 watt, need current flow in power line is 105 amperes. And 100 watt current flow and in power line is 175 amperes. And for electronic lamp, 7 watt, need current flow in power line is 30 amperes. The value of the current in table 2 above is the large excitation current is required to flow on the wire of electricity to power the light load for every size of the load or the lamp. Next, this is a characteristic that we see three size of incandescent lamp. For 100 lamp, red color. For 60 watt, indicates by blue color. And 40 watt is black color. The every lamp size of lamp is too light at 224 need a different current. For 100 watt incandescent lamp need current greater than 150 amperes. For 60 watt greater than 105 amperes, and 40 watt 70 amperes. Next, conclusion. Hits. The magnetic field energy along the electric power line can be utilized as alternative electrical energy using toroid From the analysis of the linear faults that in power lines with a large current up to 100 of amperes can be obtained power up to several kilowatts at 220 volts. The greater the electric current that flow in the power line, the greater the magnetic field energy around the power line. Second, the more toroid is installed along the power line, the more new electric energy will obtain. Then, the simulation circuit. We use three sizes of toroid. T1 is toroid big size, and T2 is middle size, and T3 is small size. And then finally, thus the paper that I can convey sendiri again yang TV Sapudin, TV Devila Ramdhani, Misi Lestari, Herawati WS, Rahmat Hidayat, Sekolah Tinggi Teknologi Mandala Bandung, Universitas Kristen Bandung. Assalamualaikum warahmatullahi wabarakatuh. Peace to all of you. Thank you very much.